A very good afternoon, everyone. I hope that all of you are doing well, and welcome to week 12 of the semester. This is week 12. You have 3 more weeks remaining till we finish off with the semester, and then you have your final exams on the 17th week of the semester. Okay, 17th is scheduled for final exam. So 12, 13, 14, 15, 3 more weeks to go. Now, in this week's class, we will be doing the following. If you would see the welcome note, so we will go over the lecture class, which is today. Okay, you're also supposed to go and attempt the lecture-based quiz. You have week 12 tutorial that needs to be attempted, and it will be discussed in our tutorial and lab class. Furthermore, in our lab class this week, we'll start looking at payback analysis, and you are supposed to work on your major project, which is due on the 31st of October. So I wish you all the very best for your major project. Okay, so today is the 11th, so exactly you have 20 more days to go to finish it up, nearly 3 weeks. Okay, now if I would go back to week 12 section of the modal shell, so I've already placed up some questions on payback analysis. Should you have free time, you can always go and do some research on it so that you have better understanding of how payback analysis actually work. If not, we will be going over this in our lab class. Now, a good news about CIN603 is after today's lecture notes, we have finished up with the entire set of lectures for CIN603. So we are quite ahead of our syllabus. That means you have 3 more weeks to go. In fact, you have 2 more weeks to go, whereby we do not have any lectures. Now, the next set of 2 to 3 weeks, that means week 13, 14, and 15, what we'll do is I will start giving you out some revision work, most likely week 14 and week 15. Now, next week, week 13, we will hold off the class to check and see where you are in terms of your major project. What is the completion rate? What all things you have done so far, and so forth. Okay. Moreover, you'll get more time to go over your lecture-based quiz. And also we are left with only 1 lab session or only 1 type of lab activity, which is payback analysis. So which is pretty good. So next week, I do not have any lecture classes. We only have labs and tutorials. Whether we have the class for Mondays next week onwards or not, I will let you know. Most likely we will have the class. Okay, but we'll go and we don't have lecture notes. We'll start looking at our labs. We'll start looking at our revision questions, and moreover, we'll get some feedback on where you are in your major project. All good, everyone? Apart from that, now, as you must have heard over the news yesterday, the restrictions for COVID-19 is easing up. Okay, we have exceeded 80% of the total vaccination rate, fully vaccination rate rather. So please revise well and ensure that you are ready for both online mode final exams and also a face-to-face. Okay. If let's say the government says, all right, the universities may operate face-to-face mode, so you will have a final exam. If not, so you will continue with an online exam. Now, like I mentioned right at the very beginning, okay, we are not so sure whether you'll have an online exam or final exam. The university is yet to verify on it because they are waiting for the government to make its call. So far, it's online mode, but just in case if the government makes some changes, so we will adhere to those changes accordingly. Outside people, without further delay, let's go over our lecture notes. So in today's class, we'll look at system architecture. Now, the word architecture means like a construction, something that you have created. Okay, another word for architecture would be a design, a framework, a structure. Okay, so this is what architecture is about. And in this week's class, we're looking at the design of a system, or how a system is constructed, how a system is designed. Chapter objectives. So provide a checklist of issues to consider when selecting a system architecture. So we will go over the checklist. describe servers, server-based processing, clients, and client-based processing. Okay, so we'll describe what a server is, what a client is, and what is a client and server-based processing systems. Explain client-server architecture, including tiers, cost-benefit analysis. Now, tiers, T-I-E-R-S, it means the levels, okay? So including levels, cost-benefit issues, and performance issues. And we'll also go around looking and comparing in-house e-commerce development with package solutions. Now, the fourth point we have well covered in before last week's lecture notes. Okay, that means if you would go and design a e-commerce or a system in-house, and you will go and outsource it or get it built by a packaged solution through an ASP, there are some benefits, there are some limitations. So we'll briefly go over that because we have already gone across it. And then we'll also go around discussing the potential impact of cloud computing and Web 2.0. Now, cloud computing, okay, anything that is up on the web and the main physical architecture is away from you, it's cloud computing. Example, emails. So if you are sending emails, you're practicing cloud computing, or you're using a component of cloud computing because the email server is not stored at your home or in front of you. It's stored somewhere out in another country. So that is practicing of cloud computing. Now, Web 2.0, this is the second generation of the web. And the major purpose of the second generation of the web is to allow easy collaboration and more of communicating work. Okay, so that's Web 2.0. Explain the difference between online and batch processing. Online means real-time processing. Batch processing means after a period of time. Okay, and we will also go around looking at the different types of network topology, including hierarchical, buzz, ring, and star models. So we'll briefly go over these models. By the way, if you're doing CIN603 fundamentals to networking, I think you're also going over these concepts. And some more objectives that you see is explain network protocols and licensing issues, describe wireless networking, including wireless standards, topologies, and trends, and you'll describe the system design specifications. Introduction. An effective system combines elements into an architecture or design that is flexible, cost-effective, technically sound, and able to support the information needs of the business. So when you're looking at a system architecture or design, you should be able to make an effective one. When we say if it's effective, is when the system is flexible, it is cost-effective. That means whatever you do is within the constraints of the cost that you can actually accommodate. Technically sound. Technically sound means without any technical errors, everything is fine-tuned and working well, and able to support the information needs of the business. System architecture translates the logical design of an information system into a physical structure that includes hardware, software, network support, and processing methods. Now, logical design, something that you get it done on a paper, something that you get it done on a software. So when you are saying that a system architecture, it's more like the design that is on paper, you try to get it done in real life. So physical architecture is what you see in front of you. It comes in the form of hardware, the machinery. It comes in the form of software, all the software that you use to run the hardware. It comes in terms of network support. That means it allows communication and transmission of data back and forth, and processing methods. System architecture checklists. So the checklist includes as such. Now, ERP or enterprise resource planning. The objective of ERP is to establish a company-wide strategy for using IT resources. And one way in which you can do that is to the use of supply chain management or customer relationship management, SCM and CRM. Okay, now enterprise resource planning, it is also a type of a software that overall manages all the IT resources and the processing capabilities of an organization. Now, if I would install an ERP system in my organization, so what I would be thinking is for the ERP to manage all the information and help me make some strategic decisions and to allow the organization to be more productive and to generate more revenue over a certain period of time. Initial cost and TCO. TCO would stand for total cost of ownership. During the final design stage, you make decisions that will have a major impact on the initial cost and TCO for the new system. You should review all previous cost estimates. Now, initial cost, it is generally the amount of money that you spend to bring in the system within the organization. Total cost of ownership is the amount of cost that incurs over a period of time for the usage of the system. The difference between the two, initial costs is the money that you spend right at the very beginning state, initial cost. TCO is the money that you spend over a period of time and you're trying to measure it. For instance, you're saying, what is the total cost of ownership for 5 years? So that's TCO, okay? And if you're saying, what is the initial cost? That means you bought the entire system for about, let's say, 1 million. So 1 million may be your initial costs. So over the period of time, your initial cost will be added with the yearly cost, giving you the total cost of ownership. Scalability. Now, this is a term that we have talked about for quite some time now. Now, the word scalability may also be called as extensibility, refers to a system's ability to expand, change, or downsize easily to meet the changing need of a business enterprise. So scalability is generally whereby you are saying that your system has the ability to be extensible. It has the ability to meet the changing, downsizing, or upsizing of the business requirements. Scalability. Especially important in implementing systems that are volume rated, such as transaction processing systems. So it's scalability, okay? Now, it is very important with TPS. Why with TPS? Because transaction processing system, it tracks the day-to-day business activities or transactions of the business. So with scalability, this is where the key role comes in, especially with TPS. You need to ensure that because generally what will happen is your business activity over time, on daily basis or on hourly basis, it is bound to increase, because you cannot, and you wouldn't want a business that would remain the same as it started back 10 years. That means the same number of customers, the same number of employees, the same number of information, the same amount of data and information and so forth. Okay, you wouldn't want that. You want your business to grow. You want more people to coming in who would be employees. You want more customers to come in, because more customers generally mean more revenue, therefore more profits. So with transaction processing system, the day-to-day activity would increase over time. So that's where scalability is put to test. Web integration. An information system includes applications. Web-centric architecture avoids many of the connectivity and compatibility problems that typically arises in marketplaces. Now, web integration is another word for just saying that your information system, you are able to integrate it with web technology. Integrating it with web technology means that whatever you are able to view it within your organization, you are able to go onto a browser, onto the World Wide Web, you're able to type in a website address, and you're able to log in from there, and you are able to step into the system that you would normally do by sitting in your office. So that's web integration. Now, why do we need web integration? Now, it becomes easy. Why? Because if you are on the move, if you're traveling from one location to the other, from one country to the other, and from one district to the other, it becomes easy for you to log in. Just imagine if you were supposed to use Moodle just from the university only and not from your homes. That wouldn't be quite nice, right? In fact, you wouldn't be able to study if that were the case. However, just because Moodle is web-centric, what you are able to do is you can log into Moodle from anytime, anywhere. I'll give you an example. Sometimes a student would send me an email saying, okay, my quiz, I'm having some issues with the quiz. Now, I cannot leave that if I see the email, I would not be able to leave it for the next time because the student and I would not be able to come together at a centric time. So therefore, what happens is I would use my mobile phone, log into Moodle. Using that, I would be able to fix the problem straight there and then. Sometimes I'm at home, sometimes I'm not at home, sometimes I'm at the university, sometimes I'm in the supermarket, sometimes I'm in the bakery, and sometimes so many different places. Just because it's web-centric and the Moodle management system or the student management system is integrated with web technologies, I am able to make so many changes all at once from almost anywhere, anytime. Okay, so that is one of the reasons. The second reason is compatibility issues. When you talk about compatibility, this English definition for the word compatibility is operate together or connect together. Now, compatibility in computing term also means the same thing, able to connect. Now, what happens is that sometimes when you have an information system introduced in an organization, your hardware, okay, the PCs may be too old, so that might be too problematic. If the PCs are too old, the new information systems or the new ERPs would not be able to operate in it. Therefore, you need to go and let's say upgrade 1,000 pieces at once or 100 pieces at once. That is very costly. Now, just imagine if you are living in Fiji, you run an organization, you have 100 staffs. So now you want to replace 100 PCs. Good PCs do not cost anything below $1,000 here in Fiji. In fact, if you're looking at very, very good PCs, they do not cost anything lower than $2,000 here in Fiji. So 2,000 multiplied by 1,000 is what? $2 million? Yeah, $2 million easily. Okay, so that means you will be spending $2 million on just buying PC. Forget about the ERP system or the information system. Forget about training the staff. Forget about all the other necessary accessory devices with those PCs. So if it's up on the web, you do not need a new computer. All you need is an updated web browser. Now, your web browser does not have too many necessary specification demands. Okay, you can run your web browser in almost in a very simple PC. Now, we have netbook, we have Chromebooks. Do you know what those are? Very small, tiny laptops with the purpose suited for just using the web. Chromebook, netbook. There's another one. I forgot about it. There's netbook, there's Chromebook. There's a browser book or internet book, something like such. Okay, so these are small tiny devices, just like a very small laptop. Okay, and what it will do is you can just use the web with it. Okay, you cannot install Microsoft Office, otherwise it might go and slow down your PC. The RAM it will have is about 1 GB max or 512, and the hard disk space will be about 30 GB to 50 GB. So if you are planning to install Microsoft Office in it, your Chromebook or your netbook would become very, very slow. If you are using a information system that is installed within the organization. However, if it's on the web, you can always do things on a web browser. All right. Legacy system interface requirements. Legacy systems mean old systems. Okay, the new system might have to interface with one or more legacy systems. Interfacing a new system with legacy system involves analysis of data formats and compatibility. The analyst must know if the new application eventually will replace the legacy system. Now, what it simply talks about here is two things. When you are installing or when you are getting a new information system in your organization, first of all, if you have legacy systems or old computer systems or old software even, okay, you need to ensure the new system and the old system, the data formats are same. If they are not the same, then you might need to go and convert the old data into the new format. Okay, now sometimes it may be impossible to do so. If it's impossible to do so, so you need to discard and then rewrite those information up somewhere. Now that is a very daunting task for the system analysis and the ICT team. Why? Because it will be years and years of load. So therefore, when you are planning things now, you need to ensure you always have a good concentration of the future demands as well. Knowing that you might need to always upgrade the system in future. So therefore, you need to ensure your legacy system and the new systems, they have the same type of data formats. Processing options. In planning the architecture, designers also must consider how the system will process data, online or in batches. When you talk about online processing, it's just like real-time processing. Everything happens in that moment and in that time. For example, when you're creating a Gmail account, there's an example of online processing. Your account is created at that point in instant rather, when you click on the sign up button. When you say it's processed in batches, is just like very similar to saying that your data is taken in and it is processed after a period of time. Let's say FNPF payments, okay? So you'll give in your form and it will process after a period of time. Now, what happens is a lot of applications get it together and then it's processed by an individual who will be vetting, auditing, and then making the process or allowing the process to go on and move to the next stage. So that's batch processing. Another example of online processing would be ATMs, okay? That's the most reasonable one. Provisions must be made for backup and speedy recovery in the event of system failure. Very important, okay? Not only your system need to be running, you must always be prepared that the system might crash at any point in time. So what you need to do is you need to have backups done every now and then. In fact, have it done every day, every evening probably, or probably every morning, or let's say once or twice in a day. Now, if you're running it twice in a day, that might make your computer system go a bit slower because the backing up of the data will also require some processing capabilities from your computer's CPU, okay? So in that case, you can back it up once in a day, let's say somewhere around 5 to 5:30, whereby the using of PCs is very minimum, or probably during lunchtime hours. Or another option is to have a online storage backing up system. For example, here at FNU, we use OneDrive. So whatever we store, it's not stored in the computer itself, it's stored on OneDrive. For instance, let me just show it to you very, very quickly. So these are my PC files. If you notice, all these are these are common files. I mean, that these are the only things that are stored in my PC. The rest of it is on OneDrive. So whatever I store, even whatever things I store on my desktop, is all just goes in directly on my OneDrive. So with that, what happens is if I would go and log into any of the PCs in FNU or outside FNU, if I go and use my computer at home, I also have OneDrive set up and synced to my computer. So all the files are pulled from this end, from this particular computing system to the other. In fact, if I would be sitting in one of the labs, if I open up that computer system, if it has OneDrive configured to it, I should be able to pull out the files from that PC as well. Everything is hosted on the web. Or another thing I could do is I could quickly go into web browser and pull out those files. So that is a good way in which you can back up your data. Okay. Now, with us, we have close to about 1 TB storage space staff given by FNU. Students also have a similar access, by the way, but it's just 15 GB, okay? 15 to 25 GB, somewhere around that. You also have Google Drive, 15 GB free space, which is a lot of space, by the way, okay? So please ensure to use it wisely. Now, at the bottom in my taskbar, you will see this particular icon, and you will see it goes, it's something like white. Have a look at this here, the blue cloud. You'll see that white refresh button coming on and off. Now, this is where it is trying to sync all the data. So if I would click on it once, okay, what you'll notice is that this is the OneDrive control bar. So whatever things I have just saved in the PC, okay, so it is uploading it up onto the web. Okay, all of these have been uploaded. So through, like this, almost everything that I've been doing for the past few years is saved on OneDrive. So this becomes very easy, and also it becomes very beneficial when you're trying to back up your data. And I would suggest for you to try it out. You have the same thing with Google Drive as well. Do try it out. Now, if you want to have the Pro version, that means you want to have 1 TB space. Okay, it might you might need to pay something to Microsoft. OneDrive is owned by Microsoft, by the way. But I don't think you will require data as much as 1 TB. Few GBs like 15 to 25 GB should be well enough, unless and until you're storing a lot of video files. Now, the next thing on our checklist is security. Security threats and defenses are a major concern to our systems analysis. The analysis must consider security issues that relate to the system design specifications. Web-based systems introduce additional security concerns. Now, when you are hosting your information system within the organization, in the organization's computing system or in-house as we call it, okay, you need to ensure a certain level of security, probably authentication levels, access levels, antivirus programs, intrusion detection softwares. Moreover, you might need it to install in virtual private networks or firewalls and so forth, okay? However, what happens is when you put things up on the web, security concern goes one level up. Why? Because it's up on the web. However, it doesn't mean that you cannot secure. Yes, you can always go and secure data even you are up on the web. For instance, you can use an antivirus program. One, you can use SSL certificates. Two, you can use proper IP-based protocols, TCP/IP protocols enhanced by in-house security systems or web-based security systems. So thus, it can provide adequate security to your data, which is up in the cloud. Moreover, if you are using a ASP, application service provider, they will also provide you with certain level of security as well. And yeah, authentications and so forth. Okay, so these are some of the security issues. Now, planning the architecture. Those were all the checklists that we had gone through. So far, we have gone over close to about 5 or 6 checklists. One is your ERP planning. Okay, 2 is initial cost versus TCO. Next, you have scalability. That means able to operate together and expand based on upsizing or downsizing. Web integration, you have legacy system interface requirements, you have processing options and security issues. So these were all part of the system architecture checklist. Next is planning the architecture. So when you're planning the architecture, especially planning it in-house or even up on the web, you need to consider what types of servers you have, what are the clients, what is the mainframe architecture, and the server-based processing capabilities. Now, if you are planning to have it done by an ASP, even then you need to consider your server details, your client details, and so forth. So clients, SPC technology exploded in mid-1980s and 1990s. Powerful microcomputers quickly appeared on corporate desktops. Now, back then, your computers were not as powerful as what we have now. Okay, nowadays we are running on i7 processors. That means a computer has close to about 7 processors. In fact, i9 has been introduced as well. That means 9 processors within your computing system. You have close to about 1 TB SSD hard drives. Now, SSD hard drives are way more faster than IDE hard drives. You have close to about 16 to 32 to even 1 TB RAM size in some of the latest PCs. And you have processing capabilities over more than 2 to 3 gigahertz per second. So that's like close to about 20 to 50 times more faster compared to what we have in 1990s. I remember when I owned my very first desktop somewhere about 1999 to 2000, okay? So my computer had close to about 128 GB of RAM, okay? Not 128 GB, sorry, 128 GB of hard disks. My RAM was close to about 64 MB, somewhere around that. Processor speed was close to about 0.8 gigahertz per second and going very, very slow. So if I would open up Google, it would take close to about 15 to 20 seconds to open up the web page. It was that slow. Nowadays, when you try to open up Google in your web browser, it doesn't even take 1 millisecond to open it up. As soon as you press enter and Google pops up. Okay. Now, users found that they could run their own word processing spreadsheet in database applications. Companies link the standalone computers into networks. Now, the last part is very important. Okay. So, especially with the linking part. So, when one standalone computer is able to link to another, that's where we have something called as internetwork. In fact, it's not internet network, it's just network. Okay. So, one computer connected to another computer, one-to-one is called a peer-to-peer network. So when you have many computers within a same building, it is still a network. However, let's say if I'm connecting Namaka campus computers with Lotoka campus-based computers, that's internetwork. That means one network is in Lautoka, one network is in Namaka. Okay, so when I connect them together, it forms inter-network. In short term, we call it as internet. Okay, the internet does not refer rather to the websites that you see. The websites that you see is called the World Wide Web. Internet means all the different networks connecting to one another. Okay, so clients still run on computers, local area and wide area networks, client-based processing. Now, local area networks, these are networks just within a building. Okay, just within a building. For example, Lautoka campus, you have few PCs in the teaching lab. So those set of PCs, if you just consider that, that becomes part of a local area network within a building. However, if I connect the PCs in the lab with the PCs in the lab in Namaka campus, it forms a wide area network. That means network that are countrywide or worldwide. Okay, now there's another type of network called as metropolitan. So LAN, MAN, and WAN. So metropolitan area network are those networks that basically link between buildings. For example, ICT building in Lautoka campus with the lecture theater at the entrance gate. Okay, so if I would try to connect these two up, so that would be called as metropolitan area network. Client-server architecture. Now, the client-server architecture basically has a standard of transmitting data. So one basically requests, so the client, look at this diagram here. So the client generally would request the server for certain requests, okay, or will request the server or send request to the server, and the server corresponds to it. So always in a client-server architecture, the client requests and the server responds accordingly. Okay, so your client server tiers, you have 2 tier, 3 tier. Now, at the moment, this is just 1 tier. So 2 tier would be is you have many other more functionalities coming in, same with 3 tier. Don't worry much about that. Okay, this is a system analysis and design course. Just know that you have client server architecture and there could be tiers as well. Now, middleware, okay, enables the tiers to communicate and pass data back and forth, provides a transparent interface, can integrate legacy systems and web-based applications. So middleware comes from the word middle and software. So when you join them together, middleware. Now what middleware simply means is you have one system, let's say on the left-hand side, another system on the right-hand side. Now they can communicate, but it becomes very difficult. So what happens is in between left and right systems, you introduce a software in the middle of these two. So the software will allow coordination of data transmission from one end to the other. Okay, let me give you another example. You have network A, network B. A network A and B, they would want to go and transmit data, but it makes it impossible. So what happens is you would bring a middleware in between network A and B. So the middleware, the software in the middle, would actually go and coordinate activities to allow transmission of data. The word transmission of data means sending data, sending and receiving of data, by the way. Cost benefit issues. Client server systems enable the firm to scale the system in a rapidly changing environment. Now, when you say scale the system, that means the system is scalable. Okay. Client server computing also allows companies to transfer applications from expensive mainframes to less expensive client platforms. What it simply means here is generally with the client server computing system, you are able to transfer data within applications at a very little cost. Okay, client server systems reduce network load and improve response time. Now, why network load? For instance, if you have come up with a system which is peer-to-peer, in other words, one computer connected to the other, what happens is both the PCs at one point in time would act like a client and a server together. Okay, whereas with the client server network, you have a dedicated server and a dedicated client. So the only work of the client is to request, and the only work of the server is to respond. So if you have two ordinary PCs, hooked up to one another, so they'll both act as client and server together. So that will put up a lot of network load on them, thus decreasing the speed and the response time. Client server performance issues in contrast to the centralized system. Now, centralized system is whereby you have a server somewhere in the middle and the server handles all the requests. A client server design separates applications and data. Distributed database management system, the system is scalable, so new data sites can be added without reworking the network design. The system is less likely to experience catastrophic failure. Now, with the centralized system, is like this: you have only one computer system, and that computer system manages everything. Okay, so just because it's just one computer which manages everything, so if that particular computer fails, the entire network collapses. However, if you have a client-server architecture, that means you'll have many computers that could be able to cater the needs of a server. So if one fails, the other would be able to come in and place or replace that particular system. Developing e-commerce solutions in-house. So guidelines: analyze the company's business needs and develop a clear statement of your goals. Consider the experience of other companies with similar goal projects. Now, I would need you to pay keen attention here. This is what you are doing in your project, by the way. Obtain input from users who understand the business and technology issues involved in the project. Plan for future growth, but aim for ease of use. So always, like I mentioned in the previous slides, you have to plan for future growth as well. I don't think there exists a business which had remained same for the past 10 years. Something changes in one point or the other. So you need always to plan for future growth. Determine whether the IT staff has necessary skills and experience to implement the project, considering training, additional resources, and the use of consultants if necessary. So again, it comes to resources in terms of technical resources. So if you have your staff, IT staff in place and on site, they need to have adequate and necessary skills to implement the project. If the project has been implemented by consultants, so the consultants need to train your IT staffs to support or provide support work. Consider integration requirements for existing legacy systems or enterprise resource planning. Select a physical infrastructure carefully so it will support the application now and later. In other words, it's telling that if you once you are developing the e-commerce solution, okay, you need to ensure that it matches or it is able to integrate well with the legacy system or the existing enterprise resource planning system. And develop the project in modular form so users can test and approve the functional requirements as you go along. Modular form is just like you have things done in steps. So if step one is done, so you get the users on board, people who will be using the system, and then get approval from them and from the management team. Once everything seems all set and all good to go, given the green light, you can proceed to the next state. That is modular form. Connect the applications to existing in-house systems and verify interactivity. So with a built-in system and the new system that you have, you need to connect both of them together and see whether they are interactive or not. Not just that, it needs to be very user-friendly as well. And test every aspect of the site exhaustively. Okay, consider a preliminary rollout to a pilot group to obtain feedback before the launch. Okay, so what it is mentioning in that case is you need to get a pilot group to test it out. Now, pilot testing is basically a phase whereby a group of users are selected and the users will go and test the system at one point in time and then approve or decline. So you do some changes, or if it's approved, you can move on to the next stage and then again get it tested by them. If it's declined with some changes, you need to go and implement the changes and get it tested again. So once you have the pilot testing done, you will try to implement that particular e-commerce solution in stages, okay? Not replacing the entire system at once, but in stages. Let's say you do it for about a department at a time. So The e-commerce system comes in for the marketing team. So the marketing team agrees with everything that you have done and they're able to use it well. You see everything is going well, then you go and implement it with the finance department. If that goes well in there as well, then you go and implement it another department within the organization. So that's pilot, group, testing, and implementation. Now, package solutions and e-commerce providers. Now, I will basically read over this because we have already gone over this. Many vendors offer 10 key systems for companies. 10 key systems is just like saying pre-made systems. Another alternative is to use an application service provider. That means organizations that is able to provide you with the system for a specific fee. Another option is managed hosting. That means you go and do it in-house. Consider the experience of other companies in the same industry. So it's always good to get some form of research done, see how similar companies in the country or in a location is doing as such. You can always go and seek advice with them, provided they're able to help you out. If not, you can always go and view and test things and research things on the web and see whether your business type is similar to the other companies which have implemented the same system, and how is it working for them? What are some of the issues they are facing? What are some of the challenges, the limitations, and so forth, and advantages, benefits, and moreover. Corporate portals. Corporate portal can provide access to customers, employees, suppliers, and the public. So corporate portal is something like this. An organization provides a web-based login. So the login system is called a portal. That means gives you access. So with the portal, the customers, the employees, the suppliers, and so many people are able to go and have access to that system. A very good example is what we have for F&PF probably, what we have for banking systems, and so forth. Cloud computing effectively eliminates compatibility issues. Why does it eliminate compatibility issues? Because you do not have to get the system implemented within the organization. And the most you'll do is you'll go and use a system just with the use of a simple web browser. Scaling on demand, that means it is scalable, requires significantly more bandwidth. So with cloud computing, you need more bandwidth in terms of your internet bandwidth, okay, more internet data. But I guess this is not a problem in a modern day world. Why? Because now look at the promotion that Vodafone and the other companies are giving. Okay, for $25, you are able to get 125 GB of data. And if that is for a month, by the way. So if in that particular month, if you're not able to pull it off, you do an automatic renewal. Let's say you have 100 GB left. So 100 plus another 125 GB, there's 225 GB. That is a lot of internet data and bandwidth. Okay. Web 2.0 envisions a second generation of the web that will enable people to collaborate, interact, and share information more dynamically. Okay. Now with Web 0.20, the main vision is for collaboration. When you talk about collaboration, it's just about you joining with other people to do some work. Interaction, that means how would you go around and interact or socialize with others, and how you go around sharing information. With the use of Web 2.0 came in social networking sites, especially the biggies, Twitter, Instagram, Facebook, MySpace, and so forth. Okay, so these were all introduced with Web 2.0. Also came in wikis. Wikis is just like a blogging site. And then you have internet operating systems. Don't worry about that. Okay, so you must know that Web 2.0, the major focus is to enable people to collaborate. It enables people to share information. It enables people to interact with one another. Instant messaging also came with Web 2.0, by the way. Processing methods, you have online processing. Now we have gone over this. Let's go and quickly read this. Because it is interactive, online processing avoids delays and allows a constant dialogue between the user and the system. Online processing also can be used with file-oriented systems. An example is given for an ATM machine. That means everything is processed on real-time basis. Batch processing, the IT operations group can run batch programs on a predetermined schedule without user involvement during regular business hours, at night, or on weekends. Requires significantly fewer network resources than online systems. So batch processing is whereby you are processing some data over a period of time or on a predetermined schedule. Okay, and what happens is quite opposite to online, but the advantage is that it requires very fewer resources at that point in time, because with an online system you need more processing, more powerful computing systems. And then you have combined online and batch processing. The combined online batch processing is whereby you combine real time with a pre-scheduled time. Okay, and a very good example is a point of sale system. So with the point of sale system, you are able to have online processing whereby you cash out your items. Okay, and at the same time, what it does, it actually goes and let's say if you let's say if I run a supermarket, so I have breakfast, FMF breakfast crackers, let's say 1,000 packets in the supermarket. So somebody comes and buys it off. So the payment is processed same time, and at the same time, let's say somebody comes and buys 2 packets. So 1,000 minus 2, that means 998 packets remaining would be updated on the system same time. Okay, it's same time. However, the sales report for the day, the accounting files, and all those things, there are accounting processes, they are done in batch. Okay, the software does it, but at a later stage in time or right at the end of the day. Network models, the OSI model. Okay, the OSI model consists of 7 layers. Each layer performs a specific function, offers a set of design standards. So there are 7 layers. You have physical layer, we'll start from the bottom 2 up. Physical layer, you have data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So with the OSI model, generally this is how networks operate on an internet or over the network rather. Okay, so these are all the things that happens that are listed in the description. Now for CIN603, I will just ask you to know what is an OSI model and what are the layers. Okay, don't worry about the description and the definition. That would be more suitable for specific for a network-based course. So we have some network protocols. You have TCP/IP, transmission control protocol, and internet protocol. Now what happens is with TCP/IP, this is the set of rules. Protocols means rules, by the way. So with TCP/IP, the rules that are used in exchange for the transmission of data. Like mentioned earlier, transmission of data means sending and receiving of data. Okay, so there are certain rules which control and ensures the data is safely transmitted over the network. And then you have file transfer protocol, also called as FTP. Now what FTP does, it allows safe transmission of safe transmission of files over the network. For instance, when you're uploading something on your Facebook profile, so you use a file transfer protocol, FTP. If you're attaching something, okay, so that's where again file transfer protocol is used. Network topology. Now topology, the word topology means types. Okay, so first of all, we're looking at hierarchical network. It mirrors the actual operation flow in the organization. Okay, the hierarchical network is just like a hierarchy. When we talk about hierarchy of an organization, we're talking about the different levels in an organization. So the network is basically designed in levels. Okay, if you look at the diagram on the right hand side, so you have levels for each and every layer. Okay, now one disadvantage of a hierarchical network is that if a business adds additional processing levels, the network becomes more complex and expensive to operate and maintain. Even just by looking at it, it is very complicated. Now have a look at the bottom layer that you have all PCs in there. Okay, however, if you look at the second tier, this is the first tier, this is the second tier. If you look at the second tier, in the second tier you also have servers in it, okay, which is connected to the third tier, which has network servers to it. So you have a network server which manages some computers in the department server, and the department server manages some common end devices. Okay, so what happens is when you have more and more devices added to them, which is likely the case, what will happen is it becomes very difficult and expensive to operate and maintain in such types of networks. Buzz network. Now, bus network can be attached or detached from network at any point in time without disturbing the rest of the network. With the bus network, you have a bus cable. So you have a cable in the middle. So the name of the cable is bus. So in the bus cable, what happens is that the devices are connected to those cables. Okay. Remember, there's only one cable, by the way. One cable in the middle, and the devices will be connected to it. Problem is, if the cable, something goes wrong with the cable, your network disrupts. Overall performance declines as more users and devices are added. Now, why does that happen? Is because as more devices are added, so you only have one single cable, there's more activity in the network, so the data transmission rate would be high. Overall, it will go and slow down the entire system. Today, the bus design is much less popular. In fact, it's not used anymore because of its disadvantages. And then you have a ring topology. Now, the ring topology, in simple terms, what it does, data flows in one direction. So if, for example, if you are using a PC and you want to extract data from the department server, so from the PC, you connect to the printer, to the scanner, to the PC, and then to the department, because data flows on one direction. Look at the arrows. It flows in one direction always. Okay, so that is the case. Now, what happens when, let's say, a printer goes out? If something goes wrong with the printer, that means you have a connection missing. So your entire network disrupts in that case. So one disadvantage of ring network is that if a network PC fails, such as a PC or server, the devices downstream from that failed device cannot communicate with the network. It's just the same as what I was explaining. If this printer goes down or something goes wrong with the printer, it fails. So you will not be able to send data from PC to the other computers. Okay, so that might be a situation in that case, in that point in time. Now, star network. The star network is whereby you have a central device. So the central device controls everything. In this case, we have a switch. So all the devices are connected to the switch itself. That means something goes wrong with the switch, your entire network disrupts. Okay. Now, the disadvantage of star design is that the entire network is dependent on the switch, like I mentioned earlier. However, in most large network, backup switches are available immediately in case of hardware failure. To get a backup switch, what can be done is you can hook up another switch to this switch and then just replace it. Or if you feel that something goes gone wrong with a computer switch, now how do you know that something goes wrong with the computer switch? Normally you have light indicators in a switch. So if something goes wrong, the lights would go off. So what you do is you take that switch off and plug in another switch and plug in all the cables, and your network will be back and up and running. Now that is not an expensive work, but it becomes a daunting task when you have a lot of devices connected to a switch. Now, mesh topology. Now, mesh topology is one of the most reliable ones. Why? Because you have more than one connection to a device. Look at this PC. So the PC is connected to the switch, the PC is connected to the server, the PC is connected to the wireless access protocol, and the PC wireless access point rather, and also is connected to the printer. That means if, let's say, the switch fails, if the switch fails here and I want to transfer data to the server, so I have a direct link to the server. Okay. If not, the switch is working. If this connection goes wrong, so the terminal will go and connect to the switch, and from the switch to the server. So many connections. However, to get that much up connections going, you need more additional cables. You need a lot of work. Okay. However, the main advantage is that it is extremely reliable. So let's read this. While this design is extremely reliable, it also is very expensive to install and maintain. Like just mentioned, originally developed for military applications. By the way, networks, if you talk about computer networks, it came from military operations. Okay, they're the ones. I'm not exactly sure of the exact year and time. It just went out of my mind. However, during the World War II, okay, that's when computer networks started coming up. Okay, to allow easy communication from one base to the other. Routers differ from switches in that they work at a higher OSI level, can connect to a larger dissimilar network, such as the internet, gateway, and proxy servers. Now, let me explain the difference of switch and routers. Now, this is the switch here in the middle. This is the switch. So what happens, the switch is able to connect to devices within the network or within the area. Okay, for example, if I have a lab and if I would like to have 30 PCs connected, so I need to have a switch which with about 35 ports or so, more than 30 ports in it, and I would be able to connect to it. So my network within the lab would work within the 30 PCs. But let's say with the lab that I've just created with the switch, I want to have another lab hooked up. Okay, so if I want to do that, that's where I will go and introduce a router. So what a router does, it provides a gateway, it provides a connection from a connection between two networks, one, or it provides a connection from the internet to a local network. So that is the major difference between the two. Switch within the building, within the room, okay, whereas a router outside access. It provides you with a gateway, or that means an opening to the outside world. System design completion. System design specification. A typical system design specification uses a structure similar to the following. So you have management summary, you have system components rather, system environment, implementation requirements, time and cost estimates, additional materials. So these are some of the lists, not so important, so I'll just read it out. User approval. Users must review and approve the interface design, report and menu designs, data entry screens, source documents, and other areas of the system that affect them. In other words, once you're designing the interface and let's say you're done with it, you must always bring it to the user to review the design. Why? Because they're the ones who will be using it and they'll tell you what might work, what might not work. Sometimes even you as a designer, you may not be able to think some of the possibilities that the user would want. Okay, so when you once actually go and get your designs reviewed by them, I think it would be way more easier to get things going and allow better efficiency and interactivity. Other IT department members also need to review the system design specification. When the system design specification is complete, you distribute the document to a target group of users, IT department personnel, and company management. So when we talk about users, generally not talking about people who will use it on a daily basis. You're talking about people who will even maintain it because they become the users of the system. You're also talking about people who will be basically managing or providing support to it. So all these people can be classified under as a user. Presentations. The first presentation is to the system analysis, programmers, and technical support staff members. Your presentation is to the department managers. Your next presentation rather is to the department managers and users from departments affected by the system. The final presentation is for company management. Management might reach one of the three decisions: proceed with the system development, perform additional work of the system design phase, or terminate the project. Now, very important. Why very important? Because when you present your idea, you will be presenting it in two stages. First of all, you'll go and present your interface idea to the technical people, to the programmers and so forth. Why to them first? They'll tell you whether if something is possible or impossible. Now, if you're thinking, let's say you're thinking a car where instead of having one steering wheels, we want to have two. For example, let's say you are a user, you're suggesting that you want to have two steering wheels. Then the person who will be designing the car, the technical people, they will tell you, no, it's impossible to have two steering wheels. If there will be two steering wheels, who will be controlling which wheel at what point in time? There's only one steering rack in a particular vehicle. So how can you have two? Okay, and besides, to have two steerings, you'll have so many different types of transmissions. So how would that be controlled? So that's impossible. This is what the technical team will tell you. Likewise, with a system design process, okay, so when you present your idea to the system analysis, to the programmers and the technical support staff members, they will tell you whether something is possible or not possible. So let's say you've got the feedback from them, then you'll go and redesign and bring it back, and then they'll say, okay, right, this is good from our end, take it to the next level. From there, you go and present it to the users, people who will be using it on a daily basis, and the department managers. So they'll go and see and they'll say, no, this is not how it's supposed to be. Why? Because when we go and click here and do this and do that, this is what happens. So this might be the possible issues. So the designing team will go and have a look at it once again, and then they'll try to implement it as per the needs of the user. Okay, so once that is done, they'll go and present it again to the department managers and the users. Once it's approved, then it goes to the company management. Okay, when it goes to the management, what the management want to see is they do not want to see what button is where, what design is where, what is the color of the logo, what is the color of the button. No, they don't want to hear that. These are people who want a high level report. A high level report will always be simple as possible, and also it will state, this is what the system is about, this is what the system will do, this is the cost, this is how much revenue to bring in, overall you have this much of profit, this will be the total cost of ownership within the 5 years range, and the system will basically be able to cater for the cost within 4 years time. Okay, and after 4 years to start gaining revenue from the system. So based on your presentation, what the management team will do is they will basically do one of the threes. They'll ask you to go and do some additional work and redesign, or they'll terminate the project, or they'll give you a green signal to go and proceed with the development stage. Chapter summary. I hope this is clear, by the way. Slide number 36. Chapter summary. An information system combines hardware, software, data, procedures, and people into a system architecture. The system analysis consider enterprise resource planning, initial cost, and TCO, scalability, web integration, legacy interface requirements, processing options, and security issues. Remember, those all are the checklists. An architecture requires servers and clients. Why servers and clients? Because the clients will be requesting the information and the server will be responding to it. Okay. Now, compared to file server designs, client server systems are more scalable and flexible. In implementing a design, an analysis should consider e-commerce strategies, the availability of the packaged solutions, the corporate portals, which are entrances to a multifunctional website. Okay. And the primary processing methods are online and batch processing. Now, with networks allow the sharing of hardware, software, and data resources in order to reduce expenses and provide more capability to users. The way a network is configured is called the network topology. Okay, and there were 4 types that we looked at. The system design specification presents the complete system design for an information system. It is presented to the users, it is presented to the management team, it is presented to the department managers and the department users, and based on the overall approval of the executives of an organization, you would then go and design the system. So that completes the lecture for week 12, and also it completes the lecture for CIN603 for semester 2, 2021. Now, here's the thing. I really appreciate your time and effort. Why? Because I think without you standing in or really going over the lectures, and some of the lectures are very long. I remember they were close to about 3 or 4 lectures whereby we had 70 to 80 slides, and we were able to cover those in a week, in a particular class, 2 hours time. Okay, if we hadn't done that, we would have had close to about 3 more lecture slides to go. Okay, so just because you bared with me, and moreover you basically entertained me for about 1.5 to 2 hours per class, sometimes very much close to 2 hours, we were able to cover. Now, this is the thing. You're done with the lecture notes. Please go and get your lecture-based quiz done as soon as possible. So you have ample time till the 31st of October to get all of it done. Try to make a checklist for CIN603. So you have lecture-based quizzes, you have your final project. So those are the 2 major things that you need to do. Now, what I will help you out with in CIN603 is I will start providing you with revision questions come next week. So in next week's class, I will start giving you revision questions. So based on those revision questions, you should start revising for CIN603 final exams. At the same time, do your major project and complete all the lecture-based quiz. Once you complete the lecture-based quiz and the project, you're done with CIN603. All you'll be left with is with the final exam. Okay. Now dedicate time take about 1 hour per day for CIN603 for your revision, for your project, and for your lecture-based quiz. So within 1 hour, take 15 to 30 minutes for your revision, take about half an hour for your project, and another remaining 50 minutes to get your lecture-based quiz done. And you should be all good. Okay, it's just 1 hour. I just need you to spend 1 hour additional apart from the normal class for CIN603. Now 1 hour per day is equivalent to 5 hours for the total number of weekdays. If you're spending 1 hour even on a weekend, so 7 hours. That's a lot of time to get a lot of things done. Honors is up to you. Okay, try to get things done. Now there are some of you who are left with a lot of lecture-based quizzes. I've gone around it over the weekend. There's a lot of students who have not done, close to about only 3 or 4 of you have been really consistent with lecture-based quizzes. The rest of you, you've been floating around here and there, thinking, okay, as I get a grip of things, I will start my lecture-based quiz. Now it's not too late even now. Okay, you have 20 days to get everything sorted. So remember, 20 days, 20 hours for CIN603 in which you can do a lot of work. All good, everyone? I hope that, and I really hope that all of you pass this course, and I am placing my bet on it because we have a really set of good students in this particular course. So I hope we get 100% pass rate for CIN603. Okay, everyone, all the very best. Now, this is where I close off the class for today. I'll see you all on Thursday's class, whereby we'll start looking at payback analysis. Till then, take care, stay safe. See you all on Thursday. Goodbye, everyone.